Alright, hello everyone, this is Mr. Crozier. I'm going to give you some help on your homework. There's nothing new on this homework assignment. It's just a lot of different types of problems that we've done. We just have to put them all together. So problem number 27 says find the equation of the tangent line. Well, we know what a tangent line looks like, right? Y equals mx plus b. And how are we going to find the slope? Well, we need to take the derivative of this, and the derivative would be y prime, and you're probably going to want to use the quotient rule. Once you use that quotient rule, plug that 1 into that, and you will output the slope. Then all you have to do is plug in the point. And what's the point? Well, the point is 1, and if I plug a 1 in here, I'd have 2 over 2. So the point is 1, 1, and that point can go in for the x and y, but to find the slope, you need to find the derivative. Alright, number 33 says find the first 4 derivatives. Well, we've only done the first derivative, and the first derivative of this would be, let's see, I'm using the power rule all the way across. Constants are gone. That's the first derivative. Well, what's the second derivative? Well, you just take the derivative of the derivative. So this is 12x squared plus 6x minus 4, constant 0. And then you can take the next derivative. Then you can take the next one, and you can keep going till you get to 0, or you can keep going to however many you need. In this one, they just wanted 4. Number 38 says it gives you an equation. Y is equal to x cubed plus x, and it says find the tangents. So what are tangents? Tangents are y equals mx plus b, y equals mx plus b, where the slope is 4. So they're telling us what the slope is. Well, so they're telling us we know that it's 4. So they're given that we have a slope of 4. But what are the x values? So when is this slope 4? Well, what is this slope? This slope is, what would that be, 3x squared plus 1. That's the slope, and we want the slope to be 4. So usually last chapter or lesson we were plugging in 0 here because we wanted the slope to be 0. Now we want it to be 4. Solve this equation and you'll get the x values for the points. Well, let's go ahead and finish that. If I subtract that over there, I have 3 divided by 3. I have 1 is equal to x squared. So x could be 1 or x could be negative 1. Those are my points here. 1 something and negative 1 something on these lines. And you can figure out this something by using this initial equation. Alright, 39 says find the points where the tangent is parallel to the x-axis. Well, what does that mean? That means, looks like this, a slope of 0. So you want this slope, take this, find the derivative, set it equal to 0, solve for x. What would x be? And it asks for a point. So instead of just writing x is equal to something, make sure you write it as coordinates, however many there are. Write it as pairs of coordinates. 36 says find the first 4 derivatives of this function, and so we just go through the line and we just keep going on down and down and find the derivatives. You could do the quotient rule here and it might work out nice, or you could change the format here. Wouldn't this just be x over x plus 1 over x? Because you have the same denominator, and then we add this. And wouldn't this just be 1, and this would be x to the negative 1? This is going to be an easier version, I think, to find the derivative. Because then if you find the first derivative, well, what's the derivative of this? Because now I can use the sum rule. That's 0. What's the derivative of this? That'd be a negative 1, x to the negative 2. And then you could keep going from there. Number 41 gives you this equation. It's a famous equation. I put a video on it in the agenda too. Find the tangents at this point and this point. So we need the tangent line here and the tangent line here. So we know the x and y to plug in. We need the slope. Well, again, how are we going to find the slope? Well, hopefully by now you know the derivative gives you the slope. And what are you going to do there? Probably the quotient rule. I don't think it's going to be easier to break it up. I would stick with the quotient rule on this one. Find the quotient rule. That'll give you the slope. Put that in for the slope, and you have the points, and you'll have your 2 equations. This is a good one to graph on Desmos. Graph this equation on Desmos, graph your 2 points, graph your lines, and everything should match up and look nice in Desmos. Alright, hope this helps with your homework.